choking on my Diet Dr. Pepper there. Alright, so this is 10.4, more with matrices, but a lot more straightforward stuff today. So if two matrices have the same dimensions, now remember dimensions are listed row by column. You can add and subtract them, and it is literally just going to be how you think you would do it. You literally just take an element, subtract it from the same element in the other matrix. And take the element, add it to the other element in the same spot in the other matrix. And then also it says you can multiply an entire matrix by a scalar product. So that means you can take a matrix and just times it by a number. So right here is a 2 by 2 matrix, right here is a 2 by 2 matrix. Notice we're not doing addition or anything. This has an equal sign. So if this is the case, guys, you would literally just say A must equal 1. Okay, see how that would be our true statement because they sit in the same spot? C must equal 5, B must equal 3, D must equal 2. So it's literally just how you would think that you would do it. Like, if I saw that, gave that to you and said, well, how do you think you do it? You'd probably think to just do that because they sit in the same position. All right, so right here, let's just, you probably honestly don't even need to take notes. Like, it's that easy. So you could probably just watch and get just as much out of it because, like I said, it's intuitive. Like, it's exactly what you would think you would do. So notice right here you would check, okay, this is a 3 rows, 3 by 2, and isn't this also a 3 by 2? It would need to be a 3 by 2 and a 3 by 2 to actually add them. So I'm going to do A plus B, so then you would literally do 2 plus 1 is 3. There's the new element there. Negative 3 plus 0, negative 3. 0 plus negative 3, negative 3. 5 plus 1 is 6. 7 plus 2 is 9. And then a half plus 2 is 2 and a half, right? And they might write that instead as like 2 plus a half, get a common denominator, but I'm not that worried about it right now. They'd probably do that and get a common denominator. All right, pretty easy, right? Now, can we do C plus A? Let's see. So C is a 2 by 3 matrix. Can we add that to A? No, because they don't have elements sitting in the same position. Do you see what I mean? So this would be, we can't. So I'm just going to put like a no solution. We can't do it. Undefined solution, whatever. So C minus D here we can do. So C minus D because they are both 2 by 3s. So you'll literally just, once again, subtract the elements. So we'll just go quick. 7 minus 6, 1. Make sure you go in the correct order, right? Oh, yeah, C minus, oh, where am I? Yeah, I'm doing C minus D. Okay. Negative 3 minus 0 is negative 3. 0 minus negative 6, won't that be positive 6? 0 minus 8, negative 8. Okay, I'm not going to circle anymore. 1 minus 1 is 0. 5 minus 9 is negative 4. Pretty easy, right? And then right here it says take 5 and multiply it to entire matrix A. So you would just literally take matrix A and you would just times 5 to all those. So you would get a 10 times by 5, you would get negative 15, wouldn't you? Times by 5 you get 0, times by 5 you get 25. It should be the same dimension. Times by 5 you get 35. 5 times a half, guys, you multiply straight across is 5 halves. So pretty straightforward stuff when it comes to adding, subtracting, and multiplying by a constant. All right, so let's do multiple things at once here in just a second. But this is all stuff you don't need to write down. This is all algebra we already know. It's not some big new thing. Look what it's saying. Like literally, take a okay, let's say that A and B are 2 matrices. Let's say C and D are scalars. That just means like numbers instead of matrices. So everybody look, isn't it true that taking some A plus some B would be no different than B plus A? Think about it. Is 1 plus 2 any different than 2 plus 1? So that's like, duh. Yeah, that makes sense. You know what I mean? I don't feel like you really need to write it down. Now this right here says if you have parentheses A plus B, then a plus C, it is no different to just move the parentheses around. A plus B plus C. And so now they've just put parentheses around this. Isn't it true, because we're just adding a bunch of stuff, that we can just even take off the parentheses? Order doesn't matter what you add, once again, right? 2 plus 3 plus 4 is no different than if I just reorder those in any order. Does that kind of make sense, everyone? But that's only true because it's addition. If this was a multiplication sign, this would be different. So just keep that in mind. If it's all addition, the parentheses don't really mean anything. So let's say we have some C, some number, times by some number times by some matrix. What you would do is you would take and multiply C to D, and then times it to a. Look, like multiply straight across. Do you guys see how it's just c dA? C times d times a. Now what a lot of people do is make this mistake. They say, well, I would distribute here and here, but that wouldn't make sense, guys. There's not an addition sign right here. You're double distributing, but that's not how multiplication works when it's not two terms. This isn't two terms. This is one term. So it's just one term. Does everybody see the difference? So don't get that confused with the one below it. So this one is, yes, we have a c plus sign d, and then times by a, so wouldn't we distribute a in? In this one, yes, because of the addition sign. So this is all stuff we already know. And then right here, same idea, you would just distribute your c in. So let's just follow, it's like literally just follow what it says to do. So this says, given these things, take c times a plus b. So you'd say, well, what is it asking me to do? You'd multiply c in. So c times a plus c times b. Well, c is 2, so let's write in what we're looking at, 2. And then a is 1, 2, 0, negative 3. Then we're adding it to our, and then we're taking c, which is 2, timesing it to b, which is 2, negative 4, negative 1, 1. So what would come first, addition or multiplication? Of course, multiplication, correct? So we would multiply 2 in. So then that would be 2, 4, 0, negative 6. We're going to add that to multiply 2 in. So that'd be 4, negative 8, negative 2, and 2. And then because these are the same dimensions, we can add the matrix together, and there's our official answer. So 2 plus 4 is 6. 4 minus 8 is negative 4. 0 plus negative 2 is negative 2. Negative 6 plus 2 is negative 4. So pretty straightforward stuff. Do you all agree? So I'm not going to do this next one. I'm just going to show you what it would look like. So we would have b times b, so that'd be negative 1 times b. So that'd be 2, negative 4, negative 1, 1. Then we're subtracting it to 2 times by 1, 2, 0, negative 3. So wouldn't I distribute negative 1 in? I could just distribute 2 in and then subtract them all, couldn't I? Or couldn't I distribute negative 2 in and then make it an addition problem? Do I need to go through that? Because I won't. I don't feel like if you don't need me to. Okay. Awesome. Okay, now this just always throws people for a little bit of a loop, but it's because we don't think about what it's asking. So it says right here, solve the matrix equation. So then it says 2x minus a equals b. Now guys, think about it. When you're solving an equation, usually you get x alone. Isn't that how we solve equations? Solve for x. It's the same idea here. So look at the true statement. 2x minus a equals b. So it says solve the equation. So that means solve for x. So let's get x alone. What would the algebra be? First step to get x alone. So we have 2x is equal to a plus b, because you added a, then what? Divide by 2, or better yet, times by a half. Let's times both sides by a half. I like that idea better. Same thing. We know that's the same thing. So that's x is equal to, we know because there's an addition sign, we would need to distribute a half in here and here. So then we would have 1/2 times by a plus 1/2 times by b. So then x is equal to 1/2 times by a. Matrix A is 2, 3, negative 5, 1, plus 1/2 times matrix B, 4, negative 1, 1, and 3. Now in this example here, guys, when we times by a half, we are going to have fractions, aren't we? We're going to have x is equal to a half times 2 is 1, then we'll have a 3 halves, then we'll have a negative 5 halves, then we're going to have a 1/2. Then we have plus, we'll distribute a half in, we're going to have a 2 minus a half plus a half, and then 3 halves here. I'm just multiplying it in. And now when we add them, we might get, I'm just going to put my official answer here, we might get fractions, which is okay. 1 plus 2, so we're now doing the same element. 1 plus 2 is 3. 3 halves plus negative 1/2. Luckily they already have common denominators, don't they? So 3 halves minus 1/2 is 2 halves, which is 1. Negative 5 halves plus 1/2. Isn't that negative 4 halves? Negative 4 halves would be negative 2. And then 1/2 plus 3 halves is 4 halves, which is 2. So there's your final answer. So pretty straightforward stuff. Now if you would have wanted, would it have been appropriate to first add up a plus b and then times by a half? Yeah, right? We could have done that. That might have even been easier, but it'll all come out the same. Awesome stuff. Okay, we are literally very close to, we have one last thing to learn. And it's matrix multiplication. You'll want to write this down. So matrix multiplication is not as straightforward as addition, subtraction, and multiplying by a constant, because multiplying two matrix takes a little bit more to it. And really, it's hard for me to give you verbal instructions. I kind of just have to show you how to do it. So here is the first rule with multiplying matrix. So remember, with adding and subtracting a matrix, they need to be the same size. That is not the case for multiplying a matrix. This does have to be true though. So everybody, if we have a matrix times by a matrix, we have to first check out the size to see if we can even multiply the matrix. So here is what we have here. Some row by column times by some row by column. So do you see I've written out 2 row column sizes here? The first thing you have to check is, do the insides match up? Do the insides match up? So the first one's column and the second one's row have to be the same. That's why I have a red flag. That has to be the same. So it's easiest just to remember the inside has to be the same. So write that down. If not, you can't multiply them. And then this is also true. I've split it apart, the 2 true statements. The next thing is the outside is going to be the size of your new matrix. So the size of our new matrix will be M by K. So now look, I've given you this example here. It asks us to multiply these 2 matrices together. The first thing you have to check is, can I do this? So I wrote out the dimensions of this one. This is a 2 by 2 matrix. We're timesing it to a 2 by 3 matrix. So I checked my insides. They are the same, 2 and 2. Do you guys see? Then I would say, okay, it's a 2 by 2 matrix. And then 2 and 2, it matches up. 2 and 2 matches up and not a 2 by 2 matrix. Our 2's and 2's match up. So we have a new matrix of size 2 by 3. That's super important. So I have the same example I'm actually going to do. I'm going to go to the next slide. Same example. I'm going to actually multiply this out and show you guys how to do it. So once again, we just saw this. These are the same, so we can, and our new matrix is 2 by 3. Anytime I have a new matrix, I write out the dimensions, and then I write in a blank matrix with those dimensions. So notice I have written in my brackets here, and then here's my first term, first row, first column. That's why I put 1 sub 1. Remember how they kind of state it like that? This is in the first row, second column, first row, third column. Second row, first column, second row, second column, second row, third column. I really recommend writing those for yourself sometimes because it kind of helps keep things straight. So this is how you multiply a matrix, okay? It's going to feel a little weird at first, so you just have to watch because I don't really know how to put this verbally. So what you do is, this is the first row, so you're going to go to the first matrix, and I'm going to just highlight to keep your eyes in the correct spot, the first row. You guys see how that's the first row? Now we're at, so first row, look, this is the first column. So you go to your second matrix, and I'm going to highlight my second column. So now how we actually multiply this out is we take the first element, and we times it to the first element here. You guys see? So we would do 1 times negative 1, then you add it to second element times the second element. So it just kind of goes in order. You guys see how I did the first times the first, the second times the second, and then they're being added. So then we have plus 3 times 0. And that would be the first row, first column in our multiplication of matrix. So we would have negative 1 plus 0, wouldn't we? So our first row, first column element is negative 1. So now I'm going to change highlighter here. Colors, just to keep our eyes in the right spot. Let's go green. So now look, first row, second column. So here's our first row, and then my second column. Now I'm at this position. So let's go ahead and do that. So we would say 1 times by 5 plus 3 times by 4. So that's 5 plus 12, which is 17. Okay, once again, changing highlighter, I guess, to pink. Sure, not pink, because that's pink. Let's go with tan. So we're in our first row, third column. So I highlight first row, then my third column. So now you would do 1 times 2 plus 3 times 7. So that's 21 plus 2, which is 23. Now guys, we have used the entire first, like we've done the first row here. So we are literally done with it. Do you see the first row ever again in the next few elements? No. So now I can just cross that out. Like we've used that, we're not going to use it again. Okay, so now we're at, let's go back to yellow shirt. We're at the second row, first column. So highlight second row, first column, and you'll just do the same thing. So we have -1 times -1, don't we? Plus 0 times 0, so that'd be 1. Now we're to green. Now we're to green. So -1 times 5 plus 0 times 4, which is -5. And then our final one is obviously this and this, correct? So we would have -1 times 2 plus 0 times 7. So wouldn't that be -2? There's your official new matrix. So it's not hard, it's just remembering how to do it. Awesome. Okay, now here's the thing, guys. I want to show you. AB does not necessarily equal BA. Meaning A times B is not necessarily the same as B times A. If it was, that's like a special matrix, which we'll talk about at a different lesson, not today though. So I'm just going to show you quickly. You might not even need to write it down. Just watch real quick one more example of multiplication here. And let's just hurry and quickly do this. So what I would do is first say, can I multiply this matrix together? Well, let's check. Isn't this a 2 by 2 matrix? This is a 2 by 2 matrix. How do we check? The inside. Yes? We can. 2 and 2. Now the outside is the new size of your matrix. So I write myself a note. I have a new 2 by 2 matrix. Now I'm in order. Look, A was first, B was second. Right here, A times B. So I've got to list it in the correct order. So this one's good to go. So now I'm going to draw in once again, my purple box here. And then I have a bunch of blanks in here. I draw them in for myself, and then it kind of keeps my brain straight here. All right, so let's see here. This is the first row, first column. So first row, first column. Do you guys see how I just kind of make myself note? So we would do 5 times 1 plus 7 times 9. 63 plus 5. 68. Okay, now we're at the first row, second column. First row, but now we're at the second column here. So then that would be 5 times 2 plus 7 times -1. 10 minus 7. 3, okay? Now we're at the second row, first column. So now I can cross that out. Second row, first column. So that would be -3 times 1 plus 0 times 9, which is -3. And then second row, second column. Second row, second column. So -3 times 2 plus 0 times -1, which is -6. Now let's do B times A. We do have to go in the correct order, so let's switch them. So now we got to go this one, have this one written first, times this one. We could just picture it. I'm just showing it for the video here. Okay, so we have a 2 by 2 and a 2 by 2, don't we? So yes, we can multiply them. Our new dimensions are a 2 by 2. So you would draw in your big purple box here. We'd put in our elements. First row, first column. So first row, first column, right? So then 1 times 5 plus 2 times -3. -6 plus 5 is -1. Are they the same? We already know they're not. Look, do you see how the first element's the same? And then so on. First row, second column. So that'd be 1 times 7 plus 2 times 0, which is 7. And then let's go to this one. This and this, right? 9 times 5 plus -1 times 3. So that's 45 minus 3, 42. Oh, sorry. 45 right here? Oh, it should be positive for your sake, right? So we have 45 plus 3, which is 48. Good catch. And then we have our second row, second column, right, everybody? So then we have 9 times 7 plus -1 times 0, so that would be 63. Now look, they are truly not the same, so we can't always assume that they're the same, so just making sure. No, I kind of just verbally said, you guys, they're not the same, but then it doesn't stick as much as showing you, so that's why I wanted to quickly show you that. Okay, awesome. Okay, this is our last wait, I swear. Oh, we're almost done here, guys. Stay with me. We're actually almost done with the lesson. This example, one last example after that. Okay, so it says write this in its linear system format, everyone. So first of all, this is a times sign right here. So we're going to rewrite this in its linear system format. So first of all, let's actually multiply out this matrix right here. So let's see if we can. Isn't this a 3 by 3, everyone? Yeah. And then this that we're timesing it to, we're timesing it to a 3 by 1. So you'd say, yes, I can, because the insides match up. So my new matrix is going to be a 3 by 1. I would make note of that. 3 by 1. So let's try in what matrix we're looking at. We have 3 rows, but only 1 column. So do you guys see I'm just closing my matrix after this? Okay, let's see what we have here when we multiply this. And then we know it's going to be equal to 4, 10, and 14. So let's go do the math. So guys, right here, first row, first column. So look, first row. Isn't there only 1 column anyway? First column. Okay, let's do it. So we have 1 times x. So 1 times x plus -1 times y plus 3 times z. Check. This is the first row, second row, first column, isn't it? So I'm at my second row, first column now. So that'd be 1 times x plus 2 times y plus -2 times z. Then I'm at my third row, first column. Third row, first column. So that will be 3 times x plus -1 times y plus 5 times z. So there's our system. Does everybody see? Now it wants it instead as a linear system. Well, what do you think our true statement would be then? I'm going to just write right here so I don't have to scroll down really small. What would be this true statement? X minus y plus 3z equals 4. True. And then we have x plus 2y minus 2z equals 10. Very good. And then 3x minus y plus 5z equals 14. Now, boom, there we go. Okay, what if at this point I said to you, great, go ahead and solve this. Then couldn't we solve by, well, since this unit, haven't we been doing like row echelon form, reduced row echelon form? It doesn't say how to solve it necessarily, but if it did, we could do it, right? We'd put it back in its matrix form. And then right here we'd put it back in its matrix form, and then we just go ahead and get it into row echelon form and then back substitute. Or reduced row echelon form, and then we'd be done. Sweet! Okay, last example is our story problem here. So this is actually it's the same thing. It's super easy, guys. It's just now putting it into context. So look, it says, in a certain city, the proportions of voters in each age group who are registered as Democrats, Republicans, or Independents are given by the following matrix. So this is matrix A. There's Democrats, look. There's Republicans, and there's Independent. And then look, the different columns are the age groups. Does everybody see? Then right here it says the next matrix gives the distribution by age and gender. Everybody grab a calculator so we can go quick through this. By age and gender of the voting population of this city. So look, here's our age. And then here's male and female. So now on part A, it says calculate the product of A times B. So you'd say, well, can I do the product of A times B? Let's check. So A times by B. This is a 3 by 3. And then this one, I'm going to write it next to it up here. This one is a 3 by 2. So check we're good. Our new one is a 3 by 2. So let's put our answer here, 3 by 2, when we do multiply this out. So I'm not going to show the work on this one, everyone. I just want you to have a calculator ready to go. So I'm going to draw in my little thing. So 1, 2, 3, and then we're having 2 columns. Okay, so let's go figure out what we're going to be out here. So everybody look. Right here, I'm going to show you. Right here, isn't this going to be Democrats straight across? Democrats is our first row. Democrat, Democrat. Then Republican will be here. Republican, Republican. So this must be independent, independent. That's going to be helpful in the future. Then also going down, this is going to be, this row is going to be males, males, males. This one will be female, female, female. Okay, great. Let's start multiplying this out here. So we're going to go to our first row, first column. So first row, guys, first column. So take your calculator. Everybody do it because we need a few in case someone makes an error. So what I want you to do is quickly for me, because we're going to go quick, and then I'm going to have somebody else do this one. A couple people. So I'm going to have you guys in that corner instead. I want you to do first row, second column. That would be finding this. You guys in the middle. Find, okay, so I'm going to have you, my dear. Can you find this first row, first column by chance? So you're going to take this and then times this, right? Plus this times this. Plus this times this. Okay, middle, you guys, if you don't mind, will you do this one? So talk together and figure out how to do that one. You guys do RF. You guys do IM. If you don't mind, and I'll do IF. Just pause. When you are ready, let me know. Okay? $13,000? Thank you. Oh, 500. Yeah. 18. Thanks. All right, so now look, it says, how many males are registered as Democrats? Literally find male Democrats. Where is that? 1, 1. Isn't Democrat male? Democrat male, so you'd say 13,500. Then it says, how many females are registered as Republicans? So, Republican female, 4,200. So, pretty straightforward stuff, guys. All right, that's the end of the lesson. The rest of the time will be yours to work on the homework.